All right, guys. So we are looking at new ways to factor. Yay! We are going to look at factoring things that are quartic. What does quartic mean? X to the fourth. Okay, so we're going to look at factoring quartics. We are going to look at factoring cubics, x to the third. We are going to factor grouping. What's grouping? What do you think that is? No, actually, that's one of my favorites. It's pretty easy. Groupings when you have four terms. So we do a grouping method for those. So we got 3 new ways of looking at factoring today. Today we're going to focus just on factoring, and then on Monday we'll get more practice factoring, but we'll also look at solving because it kind of changes things with the solving. But today is just factoring. We're not solving anything today. All right, so solve by factoring. So always remember to factor out the GCF. It's a really long line. If you want to write greatest common factor, you can, but I'm lazy. I want to write GCF. All right, but you must factor out the GCF first before doing any other factoring. So many of you forget that step, and your problems become way harder if you don't take that out first, okay? Next, after you take out a GCF, and not until you take that out, you're going to look at what is left, the polynomial, and then you're going to factor based on what you have left. And that's sometimes the hardest part, is it quadratic? What's quadratic mean? It's x squared, not 2 terms, that's binomial. Quadratic means it's x squared. Is it quartic, which is x to the fourth? Is it factor by grouping, which means it has 4 terms? Or is it the sum or difference of cubes, which is an x cubed pattern? So truly, it should be easy to recognize, right? Does it have an x squared, an x to the fourth, an x to the third? Does it have 4 terms in it? Like, it should be easy to recognize, but what makes it hard is people don't take out the GCF. Just because it starts out with an x to the fourth, does that mean it's going to have one when I take the GCF out? No, sometimes it doesn't. And then you don't follow that pattern if it's not still quartic. All right, so let's kind of start first with quadratics. You'll use guess and check to factor quadratic trinomials. So they are in the form ax squared plus bx plus c. So this is the form we start with for quadratics. We've done this all the way through. This is nothing new. But if I look at number 1, that's not quadratic, that's cubic. So why did I put it in the quadratic section? I'm going to take out a 2x. Okay, you have to take the GCF out first before you determine what pattern it fits. So I'm going to take out the 2x, and we'll be left with x squared plus 4x plus 3. Once you take out the GCF, now look, it is quadratic. It's x squared left over. Okay, so now I'm like, oh, it's quadratic. That's everything I've always factored. That's just normal factoring. Right, so we'll set up our 2 sets parentheses. Last one's positive. Both plus or both minus? Plus. Options for A, C, and we are done. There's no equal sign. I am not solving today. I am just factoring. So should the quadratic section be very hard? No, that's what we've been doing this whole time through. Right? Let's go ahead and just, for sake of we know how to do this, let's skip 2, let's jump to 3. All right, right now it looks quartic, but it's not because I haven't taken the GCF out yet. Okay, so what is the GCF at number 3? Negative 2x squared. Whew, that was painful. I heard some 4s, some 2s, some negative 4s, some negative 2s. I heard some x's thrown in there. Yeah, 4 doesn't go into 18. It goes into 16. But yeah, take out. Your brain saw that and just like assumed that's what it was. That way it worked, right? Yeah, and if the first one's negative, make sure we take out that negative. Again, I'm going to write this under here. I know I normally don't, but I want to make sure we're seeing our signs. Because when you take out that negative, all your signs change. So what are we left with here? 4x squared, positive 4x squared, and then, good, plus 9x minus 9. Yeah, you got to watch your signs when you pull out that negative. They're going to change. All right, so let's factor further. Good, it is going to be a plus minus. My last one's negative. All right, options for A, we can go 1 and 4 or 2 and 2. 2 and 2, okay. 1 and 9 or 3 and 3. If I go 3 and 3, what's going to happen to my middle term when I check that? It's going to disappear. So you want to go 1 and 4 instead? Starting to see those numbers. And some of you may need to kind of play with it longer. Some people are better at just kind of recognizing it. So 1x and 4x. So then do you want to go 1 and 9 or 3 and 3? 3 and 3? So that's 12x minus 3x, which gives me 9x. So it works? There you go. So negative 2x squared, and then an x plus 3, and a 4x minus 3. So quadratics, we've seen those, we've done those. Hopefully those are second nature by now for most of you. All right. My favorite, which for whatever reason some of you still struggle with, difference of squares. So number 4, GCF? 3x, there it is. So again, the problem looks cubic when I'm looking at it, but I can't make that determination until after I pull out the GCF. So when I pull that out, I'm left with a 4x squared minus 25. Now I can look at it and go, oh, it's quadratic. Okay, pull out the GCS before you determine what type it is. All right, and then how do you factor that? You should see those, be like, oh yeah, and just write the whole thing out. There it is. Those should be your favorite. You should get happy when you see those. Those are easy to factor. We don't really got to check much. You should just see them and recognize them. So number 5, what degree is number 5? It looks quartic, but can I make that determination right now? It actually is quadratic when I pull it out. Yeah, pull out your GCF, which would be 4x squared. So then I'm left with x squared minus 9. Now I can see, oh yeah, it actually is quadratic. That's the patterns I'm following. So then I'm going to factor at 4x squared, and then, good, x plus 3, x minus 3. And I'm good. Are we okay with difference of squares? Can I move on? All right. What if it isn't quadratic? What if it's not x squared? Can you still factor? And yes, of course you can. Now, does everything factor? No, it doesn't. But a lot of things will. So you can factor quadratics. Oops, sorry. You can factor quartics like you factor quadratics. Yeah.
Okay, so like, if you can't find at least, if you can't find a round denominator, this can be applied to a lot of what we do, but like, why does it not work if you can't find a decimal? Because like, obviously it comes to 9 regular work, but it's really ugly. But
Technically, you could pull out any number you want and make them ugly, terrible, disgusting looking things to work with. But that's not helpful.
right.
It doesn't help you in the solving process. That's why we don't.
But it does work.
Oh yeah, you can divide out anything you want, but I don't know why you would.
I'm not saying I want to.
Okay, but yeah, you could. You could. All right, so number 7, notice it is quartic. I can't pull a GCF out of here to change this, right? They don't all have an X to take. There's not a number that goes into all of them. There is no GCF. So quartics will follow just like quadratics. So quartics are going to be more like ax to the 4th plus bx squared plus c, whereas quadratics, ax squared plus bx plus c. But do you notice the exponents? This is to the 4th, and the next one's squared. It is half of that, right? Same thing here. This is x squared, and then x to the 1st. So it will factor just the same way that we factor quadratics. with one slight change. Instead of being x and x, it will be x squared and x squared. Okay? So to factor this one, there is no GCF. Last one's negative. What are your signs? Plus, minus. Options for A, it's just 1 and 1. So instead of x and x, it's going to be x squared and x squared. Because what is x squared times x squared? Would be x to the 4. So it's going to come back if I multiply this. 1 and 4 or 2 and 2? 1 and 4, and which one's negative? The 4 is negative. Now, I'm going to multiply this whole thing out so you can see it, because some people are like, wait, what? So if you would actually do a full distribution, we'd get x to the 4th minus 4x squared plus 1x squared minus 4, like terms, x to the 4th minus 3x minus 4. So do you see how it is, in fact, the same thing? Some people always question how those variables kind of come together in the middle. I did. Thank you. Thank you. All right. Are we okay there? We saw where that came from? Factor the same way? Now, this is where students get thrown. Because they factor like this, they usually do just fine factoring here, and then like, yep, good, and they move on. Does anybody notice anything about what I got going on here? Look at each of these factors. Do either of those resemble another type of factoring? My favorite? Which one of those is my favorite? Does this factor further? If I just gave you x squared minus 4 and told you to factor, what would you factor it to? That's x plus 2, x minus 2. You need to factor this further. That does factor. Does this one factor further just like it? Why not? It's got a plus sign. The 1's okay, because 1 times 1 is 1. But the plus does not allow me to. So this is x squared plus 1. Most missed problem on the test for this chapter is a problem like that, where you end up with an x squared minus 4 and nobody ever factors it further. Those are my favorites. Got to recognize those difference of squares. Okay, they'll show up a lot in the whole quartic thing because they're always x squared and x squared. So then they show up a lot more often. All right, let's look at number 8. GCF? No, 2 doesn't because there's a 15 in the middle. All right, so there's no GCF. All right, but it is quartic, but that's okay. Quartics factor like quadratics. What are my signs? Both plus. All right, we do have some options here. So we're going to have 1 and 18, 2 and 9, 3 and 6. And then C is going to have 1 and 2. You want to go 3 and 6? So 3x and 6x. 1 and 2 or 2 and 1?
Does not matter.
It does matter.
I had 2 with 3.
Yes, they would be squared. Thank you. You had what?
I had 2 with 3.
It would have to be. If I put a 2 here, that would make a GCF sitting inside there, and I know there's no GCF. Remember that trick? All right, again, if we check just to make sure, that's going to be 12x squared plus 3x squared, which is 15x squared. Now, neither of those were difference of squares, though, right? There was no minus sign, so I didn't even have to worry about it. But then they weren't perfect squared numbers either.
Oh, wow.
Look at 9. I mean, there's x's and y's in that crazy thing. Right? Well, if I can deal with an x to the 4th on the front end, no problem. How am I going to deal with a y to the 4th on the other end? It would just be a y squared and a y squared on the ends. It's not a big deal. Yeah. Forget it's there for a second. You'll be fine. You're good. They're both plus. Options for A. It's just going to be x squared and x squared. Normally, you'd look at this and be like, all right, it's 1 and 5. But I have to put that on there. So it's going to be 1y squared and 5y squared. The same way the x to the 4th became x squared, the y on the end is going to do the same idea. Now, if you check this, this is where people get thrown. They're like, well, wait, those are supposed to be together. They will be. If you multiply, that's going to be 1 x squared, y squared. Outside's going to give me 5x squared, y squared. And together they make 6 x squared, y squared. So they come together. So just because you have some extra variables, don't panic. That doesn't make it that much harder. How are we feeling so far about cortex? Hardest thing is just remembering to do x squared instead of x and x. It's really the hardest part of that. What about, does the difference of squares thing still apply with cortex? Yeah, I can factor quartic just like I factor quadratics. Same idea. So 100x to the fourth minus 9, are they both perfect squares? And a minus sign? Good. 10x squared plus 3 and 10x squared minus 3. Now, I always want to double check when I have those x squareds with a minus sign. Is that another perfect difference of squares here? No, 10 and 3 aren't perfect squares, so I'm okay to stop there. What about 11? What's the first thing we look for? GCF. Yeah, I can take a 7 out of that. If I take a 7 out, what am I left with? Some of you struggle with problems like this. 4x to the fourth. I didn't take any x's out. Is that it? Minus 1. A lot of you forget that minus 1. You just assume like, oh, it cancels out, it's gone. But then I should be able to multiply that back in and get what I started with. So if you don't put the minus 1, you're never going to get back there. All right, so once I take the GCF out, is that a difference of squares? Yeah. 4 and 1 are both perfect squares, and you got a minus sign. So how will that break down? Good. So the same way we do regular old difference of squares, just instead of x and x, you got x squared, x squared. Ooh, what if I have m's and n's? Does that change everything? Is it what? Yeah, just like we did the y on the other one. Mm-hmm. So Chris, did you know how this factors? Good. Does it matter whether you put the plus 1 first or put it last? It doesn't matter. Yeah, you have one of them plus, one minus. Ooh, now the one has m squared and n squared in it and the minus sign. Can that one go further? Why not? M and n are perfect squares, but 3 isn't. Now, had this been a perfect square, then yeah, that one would have went further, but it's not. All right, how are we feeling? Anybody overwhelmed yet? Doing okay? Of course, I'm going to slide you in slowly to all this stuff, right? All right, the next type of factoring is factor by grouping. Now, I'm going to tell you right now, most students do fine with this. Day 1, they're doing great. By like day 3 or 4, they've gotten lazy, and they don't finish it. They like do the first step of this factoring, and then they stop, which is very frustrating. All right, so this is when you have 4 terms. Now, does that mean everything with 4 terms will factor like this? No. But if you have 4 terms, this is the only method we have to try to factor it. Okay? If I give it to you in the directions say factor, it will factor. Okay, so don't panic over that. But as we get further into this chapter, we will see things that have 4 terms but don't factor, and then we look at other ways to solve them later this chapter. I know, right? There's always something. Sure you can. All right, so 4 terms, we do factor by grouping. We're going to group the first 2 terms. Right, so we're going to group the first 2 terms in a parenthesis. We're going to group the last 2 terms in a parenthesis. We're going to factor out GCFs from both. Okay, so factor GCFs from both. Factor out a 1 if there is no GCF. So you have to factor something out. If you don't, you're not going to get the right answer at the end. Okay, so if there's nothing that goes into all of them, just take out a 1. I know that seems crazy right now, but you'll see why in just a minute. All right, and then the final factored answer, we always end up with two sets of parentheses, right? That's when we factor. That always happens. Same thing here. The first factor is going to be the common factor, meaning what is the same. This will make more sense in just a minute. Just hang with me. What is the same goes in the first one, and then the leftovers go in the other one. What's left? So this should be pretty easy factoring, okay? Most students, again, don't struggle here other than they just get lazy and they stop here instead of going to this final step. All right, so let's try one. So number 13, I got 4 terms. So anytime you see 4 terms, you're going to group the first 2 and group the last 2. That middle sign goes in that second group, right, because it's attached to that 18. I am not done. That does not mean that is factored, okay? I have students try that too. That would be way too easy. What is the GCF in the first set of parentheses? X squared. All right, so let's pull out the x squared from the first set. And we get 2x plus 1. What is the GCF in the second set? Just 9? Negative 9. Okay, what's left when I pull out a negative 9? 2x plus 1. I pulled out a negative, so it changes all my signs. I'm almost done factoring already. It said, pull out GCFs, and then it said common, and then leftovers. What's common? Do you guys see the common part? Those should be the same. If they're not the same, it doesn't factor by grouping. Okay? Those are the same, so what's common is 2x plus 1. And then if I take out the common part, what do you have left? I have an x squared, and I have a minus 9. That goes here. X squared minus 9. This is common. Leftovers. Here, you know what? I know what his question is. Let me, hold on. Let me explain this another way. I know exactly what your question is. Let's make this x squared y, so I'm using y in place of this, minus 9y. You okay with that? Instead of 2x plus 1, oh, I lost that. Instead of 2x plus 1, I'm using a y. Are you okay? If I gave this to you and I said factor this, what would you do? You'd take out a y. And what would you have left when you took out the y? What did I say y was? What did I put y in place of? 2x plus 1. So really, what did I do from this step to this step? I didn't really just write down what was common and what was left. What did I actually do? I factored out a GCF. What was common to all of this? What was its GCF? 2x plus 1 is the GCF. I pulled the GCF of 2x plus 1 out, and once I take that out, I'm left with x squared minus 9. Does that make sense? Okay. That's why I teach it that way. But this sometimes helps those who are like, wait, you had 2 of those. Why didn't you write it down twice? And that's the other mistake people make. They're like, oh, I got 2, and then they put a 2 here. I'm like, no, I factored it out. That's what I was doing. I really was just pulling the common factor back out again. Now, am I done? Plus 3. There you go. Now we're done. Those darn difference of squares pop up all the time. Just be on alert. They're going to pop up. All right, but overall, I mean, differences or grouping 4 terms, it's not terrible. So let's look at the next one. Good. I think that's the first you've ever liked factoring. Yes. Found one she likes. All right, group first two, group the last two. Yep, so we pull out a GCF from the first set, which you're right is 2x to the third. X minus 2. GCF in the second set, negative 10x. What's left? What's common? Right, so that's the common. That comes out first. And then what's left over? Yes, I can. Thank you for noticing that. 2x cubed minus 10x factors further. What comes out of here? 2x comes out of there. What's left when I pull out the 2x? Minus 5. And then, where should I put that? I still have it. What should I do with it? Would it be weird if I put it here? It'd be a little weird because of that. Can I put it on the end? Is that okay? Does the order matter? Does the order matter when I multiply? No, it doesn't matter. You can put whatever order you want. It doesn't matter. All right, so kind of the biggest thing with all these different types of factoring is you want to kind of look at it once you like factor and you're like, okay, I'm good. Yeah, sometimes you can factor a little further. Okay, you just got to watch for that. Do you guys want to try one on your own? Okay, try 15. All right, so on 15, group the first two, group the last two. GCF in the first set would have been a 4x squared. So x plus 3. GCF in the second set is actually negative 1. And again, even if that was a positive x right there, I would still take a 1 from it. I need something to be here for my leftovers. Okay? Then I'm left with x plus 3. The common part or the common factor I'm factoring out is x plus 3. And then when I factor that out, I'm left with 4x squared minus 1. And then, that's a difference of squares. That's 2x plus 1 and 2x minus 1. And then the x plus 3 just comes down. So how many of you caught the difference of squares on your own? Good. And how many of you just heard me say it to someone else and you're like, oh yeah. Yeah. Good. All right, what about 16? 4 terms. Group the first two, group the last two. Good. Take out an x. You right, Quinn? What's wrong? Different order? That's okay. Totally fine. Order doesn't matter as long as you have all 3 sets of parentheses. Good. Take out a negative y. What's left when I take out negative y? Good. C minus 2. What's the common factor to both of those? C minus 2. And if I factor both of those out, I'm left with x minus y. Either of those factor further? No, there's no difference of squares. None of them have a GCF in them. Nothing like that, so we're good. Factor by grouping. What do you think? Probably everyone's favorite, right? No. No, it's not bad. All right, guys. The last type of new factoring. See, we have like flown through this new factoring today. The last new type is the sum and difference of cubes. Now, these are numbers that I don't think we recognize all that much. Like squares, we see them, we recognize them, right? Perfect squares. You probably don't recognize perfect cubes because we haven't done as much with them. So before we even get into how to factor this stuff, let's just make a list of like the common cubes that you will see. So what is 1 cubed? It is 1. Hopefully you recognize that one. 2 cubed is 8. That means 2 times 2 times 2. 3 cubed, good, is 27. 4 cubed, 64. Somebody worked ahead. 5 cubed? Good. 6 cubed is 216. 3, 5, 12. All right, I won't give you any bigger than that. Those are typically the ones that we deal with. So this is a list that you may want to keep with you, maybe right at the top of your paper, something that when you see those numbers, you recognize them. Okay? Sure. All right, so those are your perfect cubes. Just keep that in the list with you. Now, as far as factoring these, up to this point, most of what we factor, like we can kind of guess and check our way through it, right? We kind of play with the numbers, we can check them, we can kind of reason through it, figure them out. Not this one. This is one where you memorize the pattern and you just know it. Okay, now some of you may prefer that. You're like, forget that guess and check crap. Just tell me the formula, let me just use it, right? Some of you like that better. And that's how this one is. I refer to this one as the SOAP method all the time. And SOAP is referring to the signs. Yeah, kind of like that. Yep, you just memorize the formula for how they're set up and just plug the numbers in and you're good. It's done. Okay? So sum and difference of cubes is similar to like difference of squares where we have two terms. But for these, the two terms will both be perfect cubes. And obviously it will be x to the third. They're cubes, right? It'll be x cubed. All right, now the difference between the difference of squares is this can be sum or difference. It can have a plus sign or a minus sign. It does not matter. Okay, now the signs change for how we factor this. As far as the signs, because that's what we always start with, if you remember to use SOAP, right? You guys know how it is. You're in the bathroom, you're in a stall, you hear somebody else come out, and you hear them leave. Anybody else cringe as much as I do? You're like, oh my God, you did not wash your hands. Or the people that you know just ran the water and they totally didn't use soap. You all know those people. I heard somebody actually earlier today in the bathroom. Oh, it's gross. Oh, so bad. But anyway, so always use soap in real life, in the bathroom, things like that, and here. Okay? So make sure you use SOAP, which stands for same sign, opposite sign, and then always positive. That's what that stands for. Same sign, opposite sign, always positive. So filling in your parentheses for these, if it is a plus in the original problem. Now notice my parentheses are a little different. There's two terms and then there's three terms. That's different for us. We don't normally have two and then three. But the signs are the same as the original problem. And then it is the opposite of that. Right? So the same one goes here. Then it flips to the opposite sign. And then AP, always positive. That last sign is always a plus sign. So same as the original, opposite of that, always positive. That's SOAP. So you'll hear me refer to this as the SOAP method all the time. Yeah?
Why SOAP, not sum? Seems like same sign, opposite sign, positive.
All right. Okay, so same thing over here. Same sign, so it starts with a minus. It's the same as the original. Flips to the opposite, always positive. Same, opposite, always positive. All right, as far as filling in the numbers, again, you have to memorize the pattern. That's all I can tell you. The first part in the parentheses are just the cubed roots of the first part of the problem. So whatever this number is, take the cubed root, goes there. Cubed root of that one goes here. We'll get there, just hang tight. Once you do the cubed roots, then I don't care what on earth the original problem was anymore, and then I use these. Square, multiply, square. You take this one and square it, then you multiply the two of them together, and then you square the last one. It's just a pattern you have to memorize. So let's actually use the pattern with numbers so you can see what on earth I'm talking about. All right, what? Because that's a perfect cube. You walked out and missed some of the, so now you're playing catch up. All right, but we have two terms. Does not matter if it's plus or minus, but you see it's a cubed, x cubed, and our 27 and 8 on your list of perfect cubes that we made. Yes, they are. They're on your perfect cube list. So we're going to set up our parentheses, the first set, and then the second set, remember, is a little longer because there's going to be 3 terms in it. We're going to remember to use SOAP, which stands for same sign. So the original problem had a minus, so I'm going to use a minus. Then it says opposite. Opposite of minus is plus. And then AP stands for always positive. So the first thing you want to do, no matter what, is set up your parentheses and put your signs in, just like I've taught you to factor the other ways. All right. And then it's cubed root for the first part. What is the cubed root of 27x cubed? In your graphing calculators, so you can find that button, if you click on math, it's right under the green one, and it's down there on option 4. So math 4 would get you the cubed root. So the cubed root of 27 is 3, and there's an x cubed with it, so it's going to be 3x. The cubed root of x cubed is just x. And then what's the cubed root of 8? That is 2. All I've done is taken the cubed root of both of these numbers at this point. That's all I've done. That's where we start. Once I fill that in and get that, I don't care about the original problem any longer. Don't care. Then I'm going to square, multiply, square. You're going to get so tired of hearing me say that. What is 3x squared? It's 9x squared. Yep, you actually tell me what that is. Right, so the first one goes with the first part. Right, you're going to square that. Okay, then it says multiply. I'm going to multiply these together. What's 3x times 2? Don't worry about the signs. I already filled in signs first. So that's 6x. Yeah, I don't care. That's why I fill them in first. I don't have to worry about it. And then square. What's 2 squared? It is 4. And it is done. I have factored that. It looks like it should factor further. It won't. I promise you it won't. Try all day if you want. It won't. Everybody got that? It won't. I'm going to tell you that now. I'm going to tell you that every day, but it won't factor further. And guess what? You're going to try. Somebody will. It don't. It doesn't. It won't factor. Don't try. It won't. Hey, Haman, that won't factor. Okay? It won't. Angelina, that won't factor further. Yes. You're right. It won't. See, someone listen. All right, let's try another one. The more you see this pattern, you're like, oh my God, that's so easy. Like you literally just are pulling numbers like up. I promise you it is not bad. Once you do a couple, you'll get the hang of it. Yeah, you shouldn't have went to the bathroom. Did you use soap? See that? Play your words, right? Came back. All right, so here we go. 2 terms. Does it matter if that's a plus or a minus? Doesn't matter. Sum or difference of cubes. Does not matter if that's a plus sign or a minus sign. It will work no matter what. Doesn't matter. Just, right, that's how you factor it. You start with the same sign. So if it was a plus, I would start with a plus. Yeah. I'm asking, yeah, like, does it matter my original problem whether this is a plus or a minus sign? Doesn't matter. Is 125 a perfect cube? Is 1 a perfect cube? These should also be easy to recognize because they're 2 terms and they have an x cubed in them. Okay? If you see 2 terms with an x cubed, it's probably your cubed method, the SOAP pattern. All right, so we're going to use SOAP. Let's set up the parentheses. The first one's a little smaller. Second one's longer. Signs first. I appreciate that you know what's going on, though. So same as the original problem. Opposite, and then always positive. Fill in your signs first, guys. That'll make things so much easier. All right, how do I get the first numbers? Cubed root. So the cubed root of 125x cubed is 5x. And the cubed root of 1 is 1. And then it's square, multiply, square. Do I care about this problem anymore? Nope, don't care. I'm using this. What is 5x squared? It's 25x squared. multiply them together. What's 5x times 1? And then square. What's 1 squared? Is 1. Hey, will that factor any further?
No.
He's going to get a marker thrown his way.
It will.
It willn't? So do we see, though, that you have to know the pattern? There's no, like, I'm going to play around and guess and see what's going to work. Yeah, you can guess all day. Okay? Cubed root, square, multiply, square. Right? That's what we got to do. So 19. 2 terms. There's an x cubed on that. Think this is your sum and difference of cubes? Is this SOAP? Yes. If it's got an x cubed at this point, the only thing we know what to do with 2 terms and an x cubed is this pattern. If it's not that, we're in trouble. No, it would be. It could be a plus or a minus, doesn't matter. And now difference of squares has to be a minus, but this one can be either or, which is nice. So we set up our parentheses. Yes. No, it would be difference. It's sum or difference of cubes. Sum or difference, plus or minus, doesn't matter. Doesn't matter. The way that comes into play is right here. When you fill in your signs, same. So since this is a plus, that first one's a plus. Whereas on these problems, the original problem had a minus sign, so my first sign was a minus sign. Yeah, so was that one over there too. So that's why you fill in signs first. It's going to be the same as the problem, then the opposite, and then always positive. Mm-hmm. Math 4. Math is right underneath the green button. And then option 4. So what is the cubed root of 8x cubed? 2x. Don't lose your variables. And then what is the cubed root of 1? Bless you. And then I don't care about the original problem any longer. Because from there, it's square, multiply, square. What is 2x squared? 4x squared. Multiply, what's 2x times 1? And square, what's 1 squared? It's like you use the first one, you use them together, and then you use the last one, right? Square, multiply, square. Well, let's factor further. 2x and 1. Yep. I'm done. You guys, number 20. That will not factor further. All right. So setting up parentheses. Same, be a plus. Opposite, always positive. Cubed root of x cubed, just x. Cubed root of 343. And then it's square, multiply, square. Don't care about that. So square the first one. X squared is x squared. Multiply x times 7. And then square the 7. 7 squared is 49. Will this factor further? No, it never will, I promise you. And we are done. All right. For the most part, you guys seemed okay. A couple of you a little iffy. But I'm going to give you guys the last part of class. We have about 15 minutes or so. We can work on homework tonight, okay? Quinn?